center of mass or the center of gravity is the point where the entire weight of an object appears to act. So in some cases, you'd have point masses and you'd have masses only at one specific point, and you would know that that's where you would mark the position of weight. In some cases, it won't be. In some cases, you'd have two-dimensional sheets, planar objects, or three-dimensional objects, and you still have to mark weight acting on them. So for that, the certain approaches by which you find where you have to position the weight acting. So what we're talking about is that if you're given an object and you have to mark forces, amongst other forces, you would be required to mark weight, and when you would be required to mark weight, you have to know where is the center of mass or where is the center of gravity. So this thing is an extract from your formula sheet. This will be part of your formula sheet, so you can always look at it in case if you're confused about something. But see, the thing is that for some objects being uniform, it would be very easy for you to figure out where exactly is the center of mass. So if it's a rod and it's a uniform rod, and the examiner will say if it's a uniform rod or a non-uniform rod, it's a uniform circle or a non-uniform circle or a sphere, it's a uniform cube or cuboid or rectangular sheet. If it's uniform, then weight would be acting right at the center. If it's non-uniform, you can't figure out. So the examiner would sort of tell you something about it, that where he thinks the weight might be acting. For uniform, you'd know that for a rod, it should be right at the center of it. For any circle or sphere, again, it's an object for which you can judge quite easily that it would be at the center of that sphere or circle or rectangular sheet. So कुछ ऐसी objects हैं which are very symmetric in shape and you can easily mark where exactly you think the weight must be acting. But for others, you have a certain sort of a guideline given. Like for example, for triangles, you're being told that for triangular lamina, it will be 2/3 along median from the vertex. अब ये लिखा हुआ तो है, but of course, when you are doing it in exam, you need to understand what is meant by median and what does it actually mean 2/3 median from the vertex. So the three endpoints, these are called the vertices of a triangle. And median is a line which joins any vertex to the midpoint of the opposite side. So vertex to the midpoint of the opposite side. So this should be divided into two equal halves, and you draw a line that would be median. And when you draw a median, it's along that line 2/3 from the vertex and 1/3 from the side. तो अगर आपने एक median draw कर लिया है, median आप कैसे draw करेंगे? From vertex to the midpoint of the opposite side. And once you've drawn that median, if you divide that median in the ratio of 2:1, 1 nearer to side, 2 nearer to vertex. तो जब आप उसको डिवाइड करेंगे तो जिस पॉइंट पे वो डिवाइड हो रही होगी इन द रेशियो ऑफ 2/3 and 1+2:1, वो पॉइंट आपका सेंटर ऑफ मास या सेंटर ऑफ ग्रेविटी होगा. और this point, I mean, you can find this point by considering any vertex and its corresponding opposite side. Means you could take this vertex and the midpoint, this vertex and the midpoint, and then you can draw a line and then divide that into 2/3 and you would get the median. तो ये जो आपके पास point आएगा, जो कि center of mass होगा, whether you use one median, second median or the third median, you'll get the same point. Basically, in other words, this is also telling you one fact about the medians, that all of the medians would intersect at the center of mass. तो अगर आप तीनों medians बना देंगे तो तीनों medians एक ही जगह पे intersect कर रहे होंगे, और तीनों medians जब जहाँ intersect कर रहे होंगे वो तीनों medians 2:1 के ratio में divide हो रहे होंगे, and the point where they meet would be the center of mass. I have seen lesser questions or almost no question where you had to draw a median and you had to sort of find the center mass that way. This is something that I've seen more often in questions, a lot of right angle triangles kind of situations. अगर if this side is divided 2:1 ratio, तो इसका मतलब अगर आप एक यहाँ से एक हाइट ड्रॉ करेंगे, तो जब मीडियन अलोंग दैट लाइन अगर आप ढूंढना चाहेंगे किस हाइट पे होगी, तो वो भी 2:1 रेशियो में ही डिवाइड होगी. दैट्स बाय यूजिंग सिमिलर ट्रायंगल्स. सो व्हाट आई एम ट्राइंग टू से इज कि आप मीडियन नहीं बनाएं, आप सिर्फ एक परपेंडिकुलर ड्रॉप कर दें टू द बेस. और जब आप एक परपेंडिकुलर को ड्रॉप कर लेंगे टू द बेस, और उसके बाद अगर आप उसे भी डिवाइड कर लेंगे 1 और 2 के रेशियो में, तो मीडियन उस सेंटर मास उस पॉइंट पे एग्जैक्टली नहीं लाई कर रहा होगा, बट उस लेवल पे जरूर होगा. इट वुड बी एट द सेम लेवल. आई मीन इफ यू कुड डिवाइड इट इनटू 2:1, सो यू नो दैट सेंटर मास वुड बी लाइंग एट दैट लेवल. तो जैसे मैंने आपको बताया कि I see a lot of questions like these where you have a right angle triangle being given like this, or maybe you would have an isosceles triangle being given like this. तो इसमें देखिए, आप मुझे इधर से पता चल गया कि if I draw this vertical height, तो जो सेंटर मास होगा वो यहाँ से 1 और ऊपर से 2 के डिस्टेंस के ऊपर होगा, यानी इस लेवल पे होगा. ऐसे ही अगर मैं दूसरी साइड में देखूं तो दिस इज 2, दिस इज 1, तो ये इस लाइन के अलॉन्ग होगा, और फिर इनकी इंटरसेक्शन से मैं इसका सेंटर मास डिटरमिन कर सकता हूं. तो जस्ट कीप दिस डायग्राम इन माइंड कि जब आपके पास इस तरह की सिचुएशन है, तो आप देख रहे हैं मैंने मीडियन नहीं ड्रॉ किया है, लेकिन मैंने ये फैक्ट यूज किया है कि अगर मैं कोई भी हाइट ड्रॉ करूं ट्राइंगल के फ्रॉम एनी पर्टिकुलर बेस, तो उस हाइट के हिसाब से the center of mass would be 1/3 from the base and 2/3 from the top. If I draw any height with respect to any of the base, then it would be 1/3 from the base and 2/3 from the top. So I know that if I draw this as the height, then 1/3 from the base and 2/3 from the base means that center of mass would be along this line. ये मैंने जज कर लिया, मुझे पता है center of mass इस line के along है. अब जब I know that center mass is going to be along this line, अभी फर्स्ट करें मुझे नहीं पता कि सेंटर मास कहाँ पर है, लेकिन मुझे ये पता है कि इस लाइन के ऊपर है. Now I do a similar thing with considering this side as the base, and I know that if this is the base and if I draw a height, then it would be 2/3 from top and 1/3 from the base. So I know that center mass would be 2/3 from top and 1/3 from the base. So I know that it would be along this level. तो मैं ये भी जज कर सकता हूँ कि center mass is going to be along this line. और जब मैं कोई भी ऐसी दो लाइंस जज कर सकता हूँ जिसके along center mass है, तो I know that अगर मैं claim कर रहा हूँ कि center mass is on this line, if I'm claiming that center mass is on this line, so it must be at the intersection of the line. तो triangles बहुत आते हैं, हम जितना ज्यादा टाइम ट्राइंगल्स में लगाते हैं वो काम है, क्योंकि ट्राइंगल्स ही जनरली आपसे पूछे जाते हैं ज्यादा सवाल में. तो आपने बस ये ध्यान में रखना है कि सर हम अगर ट्राइंगल में कोई भी हाइट ड्रॉ करें, तो हमें उस हाइट ड्रॉ करके पता चल जाता है कि बेस से तो 2 रेशियो, वर्टेक्स से 1 रेशियो पे सेंटर मास डिवाइड हो रहा होगा. दैट वुड बी अलोंग दैट लाइन. अब जैसे अगर मैंने ये नीचे एक और डायग्राम बनाई है, अब ना इफ इट्स अ यूनिफॉर्म ट्राइंगल गाइस, so you would know that sir the center mass is supposed to be lying along this line. ठीक है, इस लाइन के ऊपर लाई कर रहा है, लेकिन हमें एग्जैक्टली नहीं पता कि सेंटर मास कहाँ पर होगा. We know it's going to be along this line, but we don't exactly know where exactly would it be. Unless we use the fact that it's going to be, if this is the height of the triangle, then it's going to be 2/3 from the top and 1/3 from the base. तो मुझे medians बनाने की जरूरत नहीं है. I can directly judge that this is the point where the center mass is going to be. तो दो चीजें आप ले लें. अगर आप मीडियन ड्रॉ करते हैं तो उसमें भी 1:2 के रेशियो से आपका सेंटर मास डिवाइड हो रहा होगा. अगर आप मीडियन नहीं ड्रॉ करते हैं और आप कहते हैं कि सर अलोंग द हाइट है, तो आप उससे कम सेंटर मास का लेवल, अगर पॉइंट नहीं जज कर सकते तो आप लेवल जज कर सकते हैं कि सेंटर मास किस लेवल पे मौजूद होगा. So that would be again in the ratio of 1:2. Let's say the triangle is like this, and you want to see where exactly, you don't want to see the exact location of the median, but you want to see what's the level of the median. Median किस level के ऊपर है, तो आप इसकी height draw कर सकते हैं, और after drawing the height आप कहेंगे कि सर अगर मैं इस पूरी height को 1:2 के रेशियो में डिवाइड कर लूं, 1 from the base, 2 from the top, तो ये सेंटर मास तो नहीं होगा, लेकिन ये मुझे बताएगा कि सेंटर मास इस लेवल के ऊपर कहीं मौजूद है. तो इसलिए मुझे एक तो बात ये पता चली कि ये ट्राइंगल जो है, अगर मैं इसमें ये हाइट ड्रॉ कर लेता हूँ, दिस इज द हाइट, तो आई नो दैट सेंटर मास इज गोइंग टू बी 1:2 रेशियो. एक तो चीज मुझे ये पता चल गया. नाउ इफ दिस इज 1:2 रेशियो, तो मुझे ये पता चलता है कि इट वुड बी अलोंग दिस लाइन. लेकिन क्योंकि ये आइसोसेलेस ट्राइंगल है एंड इट्स लाइक सिमेट्रिक ऑन बोथ साइड्स, and this line divides the triangle into two equal halves, so I knew that the center mass would be lying along this line as well. If
Oh,
it's lying
okay.
along this line and this line, so that means it should be lying here. If you have a hemisphere, so median would be along the radius, which you draw right in the center, and it will be along that radius in such a way that from circumference it will be 5/8 of the ratio. From the center it will be 3/8 of the ratio. आपको याद नहीं रखना है, बस मैंने डायग्राम बना दिया है और ये लिखा हुआ है solid hemisphere 3/8 r from the center. So I know that for a solid hemisphere, if ever I get, जैसे मैंने कहा बहुत कम possibility, लेकिन आपको पता, आपके part of syllabus है, one off आता है, तो 3/8 from the center along the radius है and 5/8 from the circumference along the radius है. ऐसे ही अगर आपके पास हेमिस्फेयर है, सॉलिड हेमिस्फेयर नहीं है, जस्ट अ हेमिस्फेयर, so it will be 1:1 ratio. ये देखें इस तरह से लिखा हुआ है. For a hemispherical shell means hollow, it's half r from the center. Again something I don't need to learn, मुझे याद रखने की जरूरत नहीं है. अब दो चीजें और आ जाती हैं, सर्कुलर सेक्टर, सर्कुलर आर्क. अगर आपके पास आर्क ऑफ अ सर्कल है, तो आप arc of a circle के साथ, obviously that arc must be of certain sector. It must be a sector that whose arc I'm talking about. So there must be have a center of that circle. So you suppose that that sector has an angle 2 alpha. Obviously you would know, ये तो आपको साफ देख के पता चल रहा है कि symmetrically the median should be, the center of mass should be along this line. ये तो आपको पता ही है. बाकी इसका डिस्टेंस कितना होगा सेंटर मास का, इसके लिए आपको फॉर्मूला दिया हुआ है, which is r sin alpha upon alpha. The angle is 2 alpha and r sin alpha upon alpha आप अगर कैलकुलेशंस में पुट करेंगे, you'll get the position of the center of mass. इसी तरीके से अगर आपके पास arc नहीं है, this is only arc which was definitely taken out from a certain sector of a circle. But if you have a whole sector of a circle, then in that case, it would be, again, you know, sir, by looking at it, I know that it should be along a radius that is halfway for an angle. यानी total 2 alpha है, अगर मैं इसको half और यानी alpha और alpha में break कर लूँगा, तो मुझे पता है along this line होगा. But how far away would be the center of mass? The formula is given to you, 2r sin alpha over say alpha. Again, something I don't need to learn. ये दोनों चीजें मुझे दी हैं. Obviously, the frequency of asking these questions is very little, but I mean, it's there and you should know. ऐसे ही cone है, for cone, it will be 1/4 from the base. ये आपको पता है cone है, तो cone में it must be along the height. But how far above the base or how far below the vertex? It's 1/4 above the base and 3/4 below the vertex. ये भी मुझे याद नहीं करना है. This was also given to me. 3/4 from the vertex. लेकिन I just should be able to recognize these center masses. अच्छा, अब Guys, after this, the other thing you need to identify is the fact that this is an individual. Would the angle be in radians? Yes, the angle is going to be in radians. अच्छा, अब basically from here onwards, जैसे आपने कहा कि सर हम एक particular ऑब्जेक्ट है और उसके लिए अगर हम उसका सेंट्रल मास लोकेट करना चाहें, so we're going to use this table. This table is going to be given to us in the formula sheet. I've tried making diagrams as well so that like there's more of a visual understanding of what this table actually means. But this information is going to be given to me, and for individual object, I can find out the center of mass. मैं किसी भी एक particular object का center of mass determine कर सकता हूँ. But sometimes what's going to happen is that I would have composite bodies. And once I have composite bodies, I may be required to find out the center mass of those composite bodies as well. What does that mean? That means, let's say I have a rod, right? And this is a uniform rod. And it has two masses attached to it. Suppose it to be a uniform rod of mass, let's say 3 kg. And there is a 2 kg mass attached over here, and let's say there is a 5 kg mass attached over here. And this is, let's say, 2 meters, and this is, let's say, 3 meters. Or I want to find out the center of mass of this composite object. This is basically a different thing where you have to find the center masses of composite bodies. So what you do is that you suppose that you're basically trying to figure out, okay, there are 3 different weights acting here: weight of a 2 kg mass, weight of a 5 kg mass, and weight of the rod itself, which is 3 kg. These 3 different masses are producing obviously a certain weight effect. And where that entire weight seems to be acting is something we're trying to figure out. Okay, it's up to us. It's up to us, but what we can do is that we can just take some point as our axis. So let's say I take this point X as my axis. And we say that sum of moments of individual weights is equal to single moment produced by combined weight. This is how we sort of logically comprehend it, that one weight is producing a moment, there's another weight producing a moment, the third weight is I want to see that all 3 together, where exactly would all 3 together produce an effective weight. And you do that in terms of moments, that the moment produced by 2 kg plus the moment produced by 3 kg, weight of the rod plus 5 kg moment. And some of these moments must be equal to the combined moment of the 3 masses being put together. So I would say that 2 times 10, that is the weight of 2 kg mass, times 2, that is the moment of 2 kg mass, plus 5 times 10 times 5. This is 5 kg, multiplied by 10 becomes the weight, times the 5 times 5, that's the moment arm, plus 3 times 10 times 2.5, because I know that if it's a uniform rod, its own weight must be acting right at the center. So the total rod is 5 meters. So its center mass would be 2.5 meters from both sides. So from X, it should be 2.5 meters. This must be equal to a single moment produced by the total weight. यानी मैं suppose कर रहा हूँ कि अगर ये सारा weight एक जगह लग रहा हो तो ये कितना moment produce करेगा? That's what I'm trying to figure out. The total weight would be 2 plus 5 plus 3. That is 10 into 10. एक 10 तो मैंने mass के लिए कर लिया, into 10 यानी क्योंकि मुझे पता है कि W जो होता है वो M times G के बराबर होता है और G is 10. अच्छा, अब वो किस डिस्टेंस पे ऐड कर रहा होगा वो डिस्टेंस मुझे निकालना है. That's the distance I need to calculate. So guys, I'm getting my answer as 3.65. 3.65 meters. And that is the combined center of mass of these three different weights. तो अब एक इफेक्ट आ रहा है 20 का, एक इफेक्ट आ रहा है 30 का, एक इफेक्ट आ रहा है 50 का. और मैं ये सोचता हूँ कि if I combine all of these weights, where exactly would that weight be acting to produce the same turning effect, same rotation effect? So I said that the combined weight, I don't know where it's acting, but the combined weight is what? 100. And I'm trying to figure out what is the distance of that combined weight. So guys, this is just a logical comprehension behind it, but we actually don't do it like this. We just use this formula. It's like, and right now whatever I've talked about is just something that's applicable to this particular formula. So you see, this becomes the overall formula, which becomes W1 times X1 plus W2 times X2 plus W3 times X3 and so on and so forth. जितने भी weights हैं आपके, तो आपने ये formula डायरेक्ट लगाना है, divided by the sum of all the weights, which is basically what this is. W times X1, W2 times X2 plus W3 times X3 divided by all the weights, which is 10 times 10. So you won't be doing this, whatever I've done here. You'd be just directly applying the formula, this formula, and you'd be able to get yourself the point where the whole weight seems to be acting, the point where the center of mass is. Or क्योंकि W, since W is mg, so you know if you replace this by m1g, m2g, m3g, m1g, m2g, m3g, so there will be g in the numerator and denominator, so that will sort of cancel out. And if that cancels out, so you can just directly use masses, and you can use masses to calculate yourself the center of mass. Which means what? Which means when I be like, sir, I understand what's going on here, but then I'm just going to learn the formula. So I'm just going to use the formula as 2 times 2 m1x1 plus 3 times 2.5 m2x2 plus 5 times 5 m3x3 divided by m1 plus m2 plus m3, 2 plus 3 plus 5. And that will give me the point where the center of mass would be. And hence, guys, more importantly, we'd be using either this formula or this formula. That's what we're going to be doing. Now, guys, thing is that this is a one-dimensional object. This is a one-dimensional object. But you might probably end up getting some sort of two-dimensional objects as well. Like, for example, I would say I have this rectangular sheet attached to another rectangular sheet. So it's like they're sort of embedded with each other. They're attached with each other, right? And I know that this has a mass of, let's say, I know the mass of one sheet. So let's say I have two rectangular sheets which are uniform. As I said, the easiest way to put a question is telling you that they're uniform, because that way you know where exactly the center masses of there individually must be. So and let me just give you some sort of dimensions with it as well. Let's say this is 4 meters. Let's say this is 5 meters. Let's say this is 2.5 meters, and let's say this is 2 meters. And so they are combined with each other. They're just making one sheet out of, this is how the shape of the sheet is like. And I can sort of split this up into two rectangles. And I could be looking to find out the center mass here as well. So for that matter, what you did, this is a two-dimensional situation. So you have a similar formula, just like you have a formula for x. It's like you have a formula for x bar, which is the center of mass, x coordinate. But we just need this formula for a object which is along one dimension, along a straight line. But for two-dimensional object, there would be x bar as well as y bar. So you have to find, it's more like finding out the coordinates of the center of mass, just like you're doing coordinate geometry, and you have the x coordinate of the center of mass, you have y coordinate of the center of mass, and you have to find both of them. So what you're going to do is that you would suppose one point as origin, whatever suits you more. I mean, कोई भी point ले सकते हैं आप, इस point को origin ले सकते हैं, आप इस point को origin ले सकते हैं, आप इस point को origin, किसी भी point को आप origin suppose कर लें. And after supposing that point as origin, you write down the coordinates of the center of mass of individual objects, which you can determine quite easily. You आपको तो total में problem हो रही है, लेकिन individual आप बता सकते हैं क्या coordinates होंगे. So like for instance, for this one, I know that its coordinate of the center of mass is going to be 2.5 on the x-axis and 2 on the y-axis. Similarly, for this one, I know that its x coordinate would be 5 plus 1.25, which is 6.25, and the y coordinate would be half of 2, which is 1. This is something that I'm using. This is something that I'm using from this information. आपके पास two-dimensional objects आ गए हैं, तो आप individual center masses with these pieces of information जज करेंगे. जब आप individual कर लेंगे, तो फिर जब आपके पास composite है, उसके लिए आप ये formula लगाएंगे. What's the formula? Formula is 10 times, x bar, m1, 10 times x1, which is 2.5, plus m2, which is 3 times x2, which is 6.25, divided by m1 plus m2, that is 13. अच्छा, इससे मुझे क्या मिल जाएगा? I'll get the x coordinate. That's coming out to be 3.37. Likewise, I could find out the y coordinate. बिल्कुल वैसे फॉर्मूला इस्तेमाल करना है आपको with y coordinate. So that'll be 10 m1 into y1, which is 2, plus m2, 3 times 1 over 30. That's coming out to be 1.77. So the y coordinate is coming out to be 1.77. So, individually, you knew right from the beginning that for individual sheets, where exactly would their center masses be? But where the combined weight of the two sheets seem to act. So you know that now. You'd be like, sir, अगर मैं एक combined weight का point यहाँ पे judge करना चाहता हूँ, so that would be somewhere here, 3.37, and so this is the center of mass of the combination of the two sheets. So, so this is how, as I said, this is how it's going to be like. And as I said, more importantly, examiner is expected to give you something like this. a rectangle with a triangle. So if it's like this, if it is like this, and अच्छा हम इसको एक और भी चीज में आइडेंटिफाई कर लेते हैं कि guys, अगर आपको ये बात पता हो कि both sheets are made up of the same material, they have the same density and they have the same thickness, same density and same thickness. तो आप देखें असल में मास किसके बराबर होता है? मास बराबर होता है डेंसिटी टाइम्स वॉल्यूम के, और वॉल्यूम बराबर होती है एरिया टाइम्स थिकनेस के. तो अगर हर जगह थ्रू आउट फॉर एवरी ऑब्जेक्ट density is same, the thickness is same, which would be the case. They will tell you if they don't give you mass, they'll tell you the area. So it'll be a uniform thickness sheet with the same material. तो आप सोच रहे हैं कि ये जो अगर मैं mass की जगह rho AT हर जगह लिख लूं तो rho, which is density, and thickness T, both will cancel out. So the formula also sort of simplifies this way. Area times x1 plus area 2 times x2 plus area 3 times x3 and so on and so forth. इस तरह से simplify हो जाता है. You can also use areas instead of mass. Okay, so let's say, I mean, I give you these dimensions here. I'd be like, ये मैंने कुछ आपको लेंथ यहाँ मार्क करते हैं. Or let's say this is 10 meters, this is 5 meters, and let's say this is 4 meters. This is made up of the same sheet of material with the same thickness. And I'm looking to find out where the whole weight seems to be acting. So what's going to happen now is that, guys, I can, as I said, I mean, I can look at the individual center masses of these. And let me just change this number a bit. Let's say this is 6. So I can find out the coordinates if I suppose any point is the origin. Let's say this is the origin that I'm considering. So I can find out the individual coordinates of rectangular sheet and triangular lamina. So, and by the way, this diagram is not drawn very well, but somehow, so we make sure that this is, yeah, now it's better. So what would be the coordinate of the center of mass of the rectangular sheet? That should be 5 and 2. And now we're going to use that piece of information. As I said, triangles come a lot often. So I use that piece of information that this side, this length is going to be 1/3 of this length. So this is 6, 1/3 of 6 is going to be 2. So I would be like, this point will have x coordinate as 10 plus 2, which means 12. And the y coordinate would be 2. And after writing down individual coordinates of the center masses, assuming an origin of my own, I can say that I can find the x coordinate. अच्छा, अब क्या फर्क आ गया? जैसे मैंने कहा weight use कर सकते हैं, weight की जगह mass use कर सकते हैं, और mass की जगह area भी use कर सकते हैं. So I've not been given information about mass. I can use the area, and I'll be able to say that that will be 4 times 10 times 5. This is A1 x1 plus A2. What's the area of triangle? Half 4 6. This is A2. The x coordinate would be 12. And divided by the total area. That's 4 times 10 plus half times 4 times 6. And by the way, guys, this particular object, I don't need to find the y coordinate because I know that this is symmetric about this line. The center of mass must be along this line, so I don't need to find the y coordinate. Or I could say, I mean, if this this point lies here, this point lies here, so obviously the average of the 2 points must also be lying along this level. So, okay, let's say this is your sheet and you're trying to find out the center mass of this. Then you put some dimensions here as well. Just like, let's say this is 6. This is 6. And let's say this is 10 as well. So, can we locate the center masses of individual objects? So, just a rectangular sheet here. Yes, I'd be able to. If I say this is the origin, it's going to be my choice, whatever point I've said it repeatedly. I'll choose what point I take as origin. And with having that assumption being done, I'd say that this coordinate would be 5 and 3, the exact center of it. And for this one, I'd be able to say that this is going to be 1/3. This is going to be 1/3 of 6. It's going to be 1/3 of 6. So that'll be 2. And 10 plus 2 gives me the x coordinate as 12. And this length would also be 1/3 of 6. I told you, you can apply the same thing to the heights. So it's going to be 1/3 vertically. And 1/3 of 6 is again 2. So I know that the x coordinate would be, the y coordinate would be 2 for this one. And hence, in this case, I'm going to have to find out both x and y coordinates. So I'll be like, the x coordinate would be a1, which is 6 times 10, into x1, which is 5, plus a2, half times 6 times 6, into x2, which is 12, divided by the sum of areas, 6 times 10, plus half times 6 times 6. Similarly, I'm going to have to find the y coordinate here. That'll be 6 times 10 times the y coordinate of the rectangular sheet, which is 3, plus half into 6 into 6, that's the area of triangular sheet, times the y coordinate of that, which would be 2, and again divided by the sum of areas, which is 6 times 10, half times 6 times 6. And this is the x coordinate is coming out to be 6.62. It's pretty much like before. And 2.77. So 6.62, 2.77. This is approximately where I can sort of, but you see, the whole practice or whole exercise was done to do what? To say that the whole weight, now I can use the combined weight of the two sheets and I can say that the whole weight is acting at this particular point and use that for further calculations.